Hi, welcome to RAR Math. Today I'm doing a series of videos on radical functions. In this video, I'm going to look at two functions, look at the inputs, the outputs, the domain, and the range. Okay, so let's start off. In this first one, the number in the parentheses is the input. So what I want to do is I want to replace x with 6. So I have the fifth root of 6 minus 4. Now the directions, what I'm going to do is I'm going to round to 2 decimal places. So I'm going to immediately put this into a calculator and round to 2 decimal places. It's not a perfect root, so decimal it is. Next, I'm going to do the fifth root of x minus 4 equals -3. Now, if this were an even root, we couldn't have a negative. But the thing about odd roots is they're much more flexible, and you can have a negative within an odd root. That's what's odd about the odd root. So to undo the fifth root, I take both sides of my equation to the fifth power. On the left-hand side, the fifth root and the fifth power cancel, leaving us with x minus 5. And on the right-hand side, -3 to the fifth is -243. I add my 4 over, and I get that x is equal to -239. Okay. Now for the domain and range. These are my favorite parts with an odd. An odd radicals graph looks either like this or like this. Either way, you can see that the arrows left and right mean that the domain is all reals. Now you could do interval notation. You could use the words all real. You could do double bar R, but you have no limitation on your input. You also have no limitation on your output. The range is also all real, which is kind of cool. So when you have an odd root, what's odd about an odd root? It's oddly easy. There are no restrictions. Okay, for my next equation, if I put the sixth root of 5,000 minus 100, again, I'm just going to throw this into a calculator. I'm not going to do any fancy calculations. The sixth root of 4,900, it's not really going to get me any further. I put this into a calculator, I get 4.12. Then I'm going to do the sixth root of x minus 100 equals 8. F of x equals 8. F of x is just another name of y. It's turning y and putting it into a function notation. So this is just saying, hey, find x, find the value of x that makes the y, the output, equal to 8. Okay, well, because this is the sixth root, the inverse of the sixth root is taking it to the sixth power. Inverses undo each other. So on the left-hand side, these cancel, leaving us with x minus 100. On the right-hand side, we have 8 to the power of 6, which is 262,144. If we add 100 to both sides, we get that x is equal to 262,244. Now the domain and range on an even root is trickier. An even root is bound by being 0 or positive. You cannot take an even root, a square root, a fourth root, a sixth root of a negative number, which means x minus 100 needs to be greater than or equal to 0. So my domain becomes x is greater than or equal to 100. We could do this in interval notation. I could say 100 to infinity. That looks fun with all the zeros. For my range, what I do is I look at the beginning and the end, the bookends of my function. Because this is 1 times the sixth root, my coefficient is 1, 1 is positive, that means my graph goes to positive infinity. There's nothing added here, which means 0 is my lowest value of the range. So my range goes from 0 to infinity, or y is greater than or equal to 0. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!